Hello students, welcome to session number 46 of unit 6. This chapter is about op-amp and timers, means operational amplifiers and timers. So in this session we will study definitions of virtual ground, common mode rejection ratio. In short, it can be spelled also CMRR and slew rate. So before going to these definitions in detail, so let us see previous sessions, what we have studied in the previous sessions. So in the previous sessions we have studied in the session number 44 op-amp definition, block diagram, operation. In session number 45 characteristics, applications, and the timer, the pin number, that is pump pin numbers, PMUA 741 pin diagram. So after this studying of definitions of op-amp, so we'll glance what is op-amp now. So op-amp is a circuit, electronic circuit that can perform many mathematical operations such as integration, differentiation, multiplication, division, subtraction, and addition. So these are the main mathematical operations can be performed by the operational amplifier. So now this I said this is an electronic circuit. This is not a component. This is an electronic circuit. So what are the components it can involve is, so it can be defined in 3 stages. The first stage is differential amplifier, second followed by the common emitter, high voltage, high gain common emitter CE amplifier, and followed by the output stage. So as we know, common emitter configuration amplifier we have already studied in a 5th unit. So the in detail, then the first operational amplifier is differential amplifier. So what is differential amplifier? This differential amplifier is a circuit which can accept 2 input signals, means it will accept the 2 input signals. So those input signals are V1 and V2, and this output is difference between the 2 inputs. That is, let us say the output is V0 and the output can be difference of these 2 inputs. So that is V0 is equal to in V1 minus V2 or V2 minus V1. So in either way, so this is a differential amplifier. So that is why it is called as a differential. So what it will do, it will differentiate, the difference of the input voltage. So suppose the input of 1 voltage, that is V1 is equal to 1 volt and V2 is equal to 0.5 volts, then only the output of the operational amplifier, that is differential amplifier, will be taken. That is V0 is equal to 1 volt minus the 0.5 volts. So this is how the differential amplifier can be defined in brief. So let us see, the differential amplifier has 2 inputs, we said. So what are those 2 inputs? So those inputs is common mode signals and the differential mode signals. We have to give 2 signals in the input of the operational amplifier. Those 2 inputs are common mode signals and the differential mode signals. So what is meant by common mode signal? When the input signal to a differential amplifier are in phase. In phase means they should V1 and V2, whatever the signals given to the input signals V1 and V2, those should be in phase. That is, they should not out of phase. Okay. So that is in phase signals exactly equal in amplitude. They are called as a common mode signals. Common mode signal, that is V1, the signals given to input terminals, that is V1 and V2. V1 and V2 are the input terminals. So through these input terminals we are going to give 2 signals. So those signals are having the same phase and the same magnitude. So then they are called as a common mode signals. It is because the common mode signals are rejected by the, whenever the common mode signals are given to that is the same phase and same magnitude signals are given to given as an input to the operation differential amplifier. So the output is not amplified because it is differential amplifier amplifies the difference between the two signals, that is V1 minus V2. And for common mode signals, this difference is 0. Hence, for common mode operations, V1 is equal to V2. So the amplified output, we won't get at the amplified output at the output terminals of differential amplifier. So let us see what is meant by differential amplifier, differential mode signals. When the input signals to a differential amplifier are 180 degree out of phase and exactly equal in amplitude, they are called as differential mode signals. So these differential mode signals are amplified by the differential amplifier. It is because the difference in the signals is twice the value of each signal for differential mode signals V1 minus V2. So the only when the difference appears between the two signals, then only we will get the difference between the output, that is V0 is equal to V1 minus V2. So now let us come to the definitions of virtual ground. So virtual ground, with the background of these, that is what is differential amplifier, definition of the amplifier, and what is common mode signals, and what is differential mode signals. So let us have the definitions for virtual ground. See, the name itself indicates that it is a virtual. Virtual means it's not real, it's not actual, so imaginary, or it can be assumed. So then that is that can be said as virtual in general. So then what is virtual ground? It is not virtual ground or not real ground. So equivalent to ground, it is equivalent. So approximately equivalent to ground. We'll assume this as a ground in some applications. In op-amps, virtual ground means that the voltage at that particular node is almost equal to ground voltage. It is not physically connected to the ground. Andre ground point ಗೆ connect ಆಗಿರಲ್ಲ. Usual ಆಗಿ ಏನು ನಾರ್ಮಲಿ ಗ್ರೌಂಡ್ ಪಾಯಿಂಟಿಗೆ ಕನೆಕ್ಟ್ ಆಗಿರುತ್ತೆ ಅಂತಂದರೆ ವೋಲ್ಟೇಜ್ ಫಿಸಿಕಲಿ ಗ್ರೌಂಡ್ ಪಾಯಿಂಟಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ವರ್ಚುವಲ್ ಗ್ರೌಂಡ್ ಅಂತಂದರೆ ಇಮ್ಯಾಜಿನರಿ ಕನೆಕ್ಟೆಡ್. ಇಟ್ ಈಸ್ ಅಸ್ಯೂಮ್ಡ್ ಟು ಬಿ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಗ್ರೌಂಡ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಫಿಸಿಕಲಿ ಕನೆಕ್ಟೆಡ್. ಸೊ ಲೆಟ್ us see what is the difference between the real ground and the virtual ground. So in virtual ground, the voltage is approximately 0, but in a real ground voltage is exactly 0. It is not assumed, it is not imaginary, it is exactly 0. So in virtual ground, not able to sink infinite current. So if it is assumed to be a virtual ground, the current cannot be synced. But in actual ground, it is an infinite current sink. So how much amount would be the current, that leakage current? So that should not, we are making it ground because the additional current should not flow through the circuit. Unwanted current should not flow through the circuit. So it has to flow through the ground. So that is called as a actual ground. So the additional current cannot flow in a virtual ground. So and no more one more thing, not electrically connected to ground, and in a actual ground it electrically connected to the ground. So this is the sketch. We can make it as a virtual ground. Here Vn is a 1 voltage, that is input voltage, that is a it is connected to the negative point of the operational amplifier, and another point is grounded. So now this point, the feedback circuit RF is connected to the virtual ground. It is virtually connected. So it is not really connected. It is assumed to be virtually connected. And an ideal op-amp will provide a infinite voltage gain. Infinite voltage gain, the ideal op-amp, but actual op-amp also will have the very high voltage gain. So, but in case of operational amplifier, that is virtual ground, the infinite calculation, so gain is equal to V0 by Vin. As a infinite gain, we have assumed that virtual ground in actual amplifier. So the voltage gain is infinite. Then Vin is equal to, that is input voltage is equal to 0, and hence the input voltage is equal to V2 minus V1. Then the V1 is connected to ground, so V1 is equal to 0. So and hence V2 is also connected to ground potential. V2 is equal to 0, since V2 is also 0. So means whenever the another input is connected, when infinite for a voltage gain infinite, then another input, one more input is assumed to be connected to the ground. This is called as a virtual ground. So coming to the next definition, that is common mode rejection ratio. So that can also be spelled as CMRR. Okay, C stands for common, M stands for mode, and R stands for rejection, and another R for ratio. So we have voltage gain. So that is two types of voltage gain, that is for a differential mode and for a common mode. So common mode means that is the two inputs are in phase, and differential mode means the two signals given to the differential mode differential amplifier is the difference between the two inputs. The V1 is different than the V2 in phase. So that is those two signals are given to the V1 and V2. Then the ratio between the differential mode signal voltage gain and common mode voltage gain is known as a common mode rejection ratio. I'll repeat, common mode rejection ratio is a ratio of common mode voltage gain to the differential mode voltage gain. So the gain can also be defined for a current gain, power gain. If it is a current gain, that is CMRR is equal to ADM divided by the ACM, or IDM divided by the ICM. So ADM stands for gain, A stands for the gain, and DM stands for the differential mode, and CM stands for the common mode. So between these two ratio, we can say the common mode rejection ratio. It is a ratio of common mode voltage gain to the differential mode voltage gain. In other words, common mode current gain to the differential mode current gain. Or the CMRR can also be spelled for the power also. Common mode power gain to the differential mode power gain. So that is, it is the common mode rejection ratio. It is always measured in a bell, that is decibel. So that is why common mode rejection ratio, the dB is taken as a suffix. That is, decibel can be defined in a previous sessions. We have studied that. So the decibel written format is D is in a small letter and B as a capital letter. So this can be in the format of dB. Okay. So CMRR is equal to 20 log 10 ADM to the ACM, or in it is equivalent to 20 log 10 CMRR, because CMRR is equal to ADM to the ACM. In place of ADM to the ACM, so that can be replaced by your letters CMRR. Okay, common mode rejection ratio. This thing you have to remember in mind, such that the common mode rejection ratio is equal to 20 log base 10 ADM to the ACM. So now this is the unit of common mode rejection ratio is bell, that is decibel or just bell. So what is the importance of common mode rejection ratio? That is the ability of a differential amplifier. Here DA stands for the differential amplifier. The ability of a differential amplifier to reject the common mode signals. The larger the common mode rejection ratio, the better is the amplifier. That is, differential amplifier is better working only when it will reject the common mode signals and is eliminating the common mode signals. So next point is, that is next definition in this section is slew rate. So what is meant by slew rate? So that is, it is a slew, it is a measure of how fast the output voltage can change. See, input voltage is given between two terminals, that is V1 and V2. So what would be the value of output? So when these voltages, the input signals are given. So how fast the voltage is magnified and it is given to the operator. So that is are the following loads. So that is spelled by the slew rate. So slew rate will have a unit. So that is measured by voltage per microseconds. So it is always measured in a voltage per microseconds. How much would be the voltage for 1 microseconds, 2 microseconds, etc. So it is always measured in a volts per microsecond. Frequency is a function of time. Yes, that is f is equal to 1 over t, or t is equal to 1 over f. So frequency and times are the reversal. So they are inversely proportional. So the slew rate can be used to determine the maximum operating frequency of the operational amplifier. The maximum frequency it would operational amplifier follows is slew rate divided by the 2 pi VPK. That is VPK means the voltage at peak or peak voltage. Peak voltage means what is the maximum voltage that can be amplified by the differential amplifier. So when the input signals are in a differential mode. So slew rate is the maximum rate at which the output voltage is capable of changing with the changes in the input voltage. Only changes in the input voltage. What is the voltage of the amplifier that can be spelled in a that can be said in a slew rate. So these are the points we have discussed in the session number 37. Yeah, 46. 46 of unit number 5, that is op-amp and timers. So what are the questions we can expect from this session is define differential mode. Okay, differential mode, common mode. So what is the definition of op-amp, operational amplifier? So what is the define slew rate, define common mode rejection ratio. So in terms they can be in the question paper they can ask also CMRR. So by knowing the CMRR, so you have to expand first, that is common mode rejection ratio. Then you can define the common mode rejection ratio. And one more thing, that is virtual ground. So with that diagram you have to define the virtual ground. I think hope you are all understanding the point. Thank you.